We just took before in the previous files that if you take out some negative charge from a conductor, the remaining positive charge, effectively, when electrostatic equilibrium is established, it has to be at the surface. So the question is, if you look at the tangential component of electric field just outside the surface when you're in electrostatic equilibrium, we said before in a kind of brief way that this tangential component cannot exist. Do you remember what the argument was? The idea is, let's assume that there is a tangential component of electric field. In that case, there are always free charges on the surface, ready to move if a force is applied to them. So if there is a tangential component of electric field, then those charges will start to move on the surface, and that means we will not be in equilibrium. And so the conclusion is that there cannot be any tangential component of electric field on the surface. There can only be a normal component. There's a more rigorous way to do this, to make this argument, and we may get to this when we get to the chapter on potential. And there's a way to prove that if the tangential component of electric field just inside the conductor is zero, then the tangential component of the electric field just outside the conductor has to be zero too. So there's a way to show this rigorously when we discuss the chapter on potential. But for now, let's just take the idea that the tangential component is zero, because if it wasn't zero, then the charges on the surface will experience a force and they'll move parallel to the surface. So this is the situation that a conductor is in. This is kind of a pictorial view of what a conductor looks like. We're plotting here the electric field just outside the surface. If you go just a very small distance outside the surface, it only has a normal component. There's no tangential component. Of course, inside the conductor, the electric field is zero. We're talking here about the electric field just outside and not too far away. If you go too far away, it could have a tangential component. In that case, we don't know exactly what the tangential component means, but it could have an electric field in any direction. But we're talking here just outside the conductor. So the question now, next we want to find in the next video is, what is the value of the electric field, this normal component of electric field just outside the conductor? What's the value of it? And as a hint, we'll be able to use Gauss's law to find this value. Try to think about it on your own and see if you can derive it.